is the one on forecasting turbulence. This is mostly because I thought it was interesting. I really went into the lecture not knowing very much about turbulence at all. So a lot of the information that I was hearing and that I was seeing and that they were asking about, I didn't know. So it was in all a huge learning experience. And so about the question of what I learned, I learned basically all of it was new information to me. I did, however, go in knowing generally what turbulence was and knowing instances in real life where turbulence will affect, the day to day. I didn't know how big of a physics problem it was and how difficult it was to understand and forecast and follow. And I didn't realize that turbulence itself was basically shadows of normal activity, chaos that it seems to be, the unpredictability of it. There is a level of predictability to it, which I really think they did a good job of pinpointing and explaining how it is possible to predict turbulence, but it is very difficult. And it's kind of a combination of multiple different formulas because you have to look at all the different motions that it is going in and understand that it is mimicking normal movements. I don't want to say normal, but standard motions, but only mimicking. So it's a shadow of it, which I thought was interesting because that is really hard to determine what exactly it's a shadow of. And I would say that in particular really sparked my curiosity. And as far as how this relates to my field of study, I'm an NRE major, which is nuclear and radiological engineering, and I'm particularly interested in the radiological aspect of that. And so turbulence does affect radiology. In fact, PCMRI turbulence mapping is a way to map turbulence. Basically, it's a form of radiology that estimates turbulent quantities. In fact, turbulent flow impacts NMR imaging. So, although turbulence does have a small impact, not small, I would say relatively minor part in radiology, it does have a part. And most of my major and most of what I plan on studying is physics. So turbulence is a big problem or question in the physics community. And so in that way, I will be continuing to deal with it and do studies that it is involved in or has some impact on. In addition to going to the lecture, I decided to do some research of my own. In the lecture at the very end, they talked about the Taylor-Covet flow because basically the lecturers and his associates' entire experiment was in 2D, and so it showed snapshots of their 2D water moving in a magnetic field and the different turbulence created by that, and then they compared their snapshots to ECS pictures and stuff, and they found the different motions, and they talked about how there were shadows of the individual motions. But unfortunately, the real world, the world we live in, is in 3D, and so at the very end of the lecture, they mentioned that the Taylor-Covet flow tried to model 3D motion. And so I looked into that farther and basically just looked at different pictures and videos of it and how it really does need more technology so that we can survey turbulence over longer periods of time.